as we start talking, we're going to start talking about I can identify different types of energy. And before we even go there, I'm going to pass out a packet of information to you. It does not have holes in the top of it. And because it does not have holes in the top of it, my rule is don't write on this. Okay? So Philip's going to come around quickly and give everybody one of those. Jesse already has one back there. Okay? You don't need a piece of paper because the next thing I'm going to give you, Peyton, you're ahead of the game. Okay? I'm going to give you a paper that has holes in it. If it has holes in it, my general rule is that you will write on it. Olivia is going to come around quickly and hand you one of those. Okay? So we're talking about different types of energy. The first thing I need to do, and we need to make sure that we know before we define and look at the different types of energy, okay, is we need to make sure that we have an understanding of what energy is. Okay? And as we look at energy, so as you look at your paper, the one with the holes in it, you've got a chart that looks like this. It's labeled Pause and Review up on my board. Okay? You've got a table and it looks just like what's on the front screen. And I'm going to go ahead and I'm going to put 4 minutes on the clock. And you have a job to complete. Okay? In that 4 minutes, you are going to use the packet that Philip gave you. And you are going to use just the front page. And you'll look at the numbers. It's page 2 and page 3. Okay? And so you are going to read only that first page and a half up until where it says types of energy. And as you read that, I want you working on filling in your table that looks like mine on the board in your notes. Okay? You didn't get this. I got some extras. I think you'll be one short. All right, so read. Yep, you're going to fill that chart out, and you got how long? 4 minutes. So I'm going to pause the recording. All right, now while we wait for the computer to catch up. Okay, let's take a minute and let's go over what you just read. And let's put it on our chart. Let's make corrections or add to it as we need to. So as we look at our pause and review, we had to look at definition and the unit that we measure it in. Okay, so what can you tell me about energy? What is energy? All right, Savannah, what is energy? All right, it's the ability to do work. So go ahead and write that in for me. The ability to do work. Do I just put the color? All right, you learn it's harder than it looks, isn't it? Okay, so it's the ability to do work. And while Savannah's doing that and working on that, how do we measure energy? What unit do we use, Carissa?
Joules.
Joules. I want you to say it, joules.
Joules.
Okay, it might look a little bit odd to you. So go ahead and write in there joules, Carissa. Okay, so energy is the ability to do work. Do you all have energy?
Yes.
Okay. All right, so sometimes it's more than others. All right, what can you tell me about work? What can you tell me about work? Stephanie?
Causes the object to move.
It causes the object to move, so that's what we're going to start with. So, causes the object to move. What else can you tell me? Yes, work causes an object to move. We're going to add something else to it underneath. So, causes the object to move. Jesse, what else can you tell me?
The rate at which the work gets done.
The rate at which the work gets done. Is that work?
No, that's power.
That's power. So you're jumping ahead just a little bit, so we'll come back to you. Causes objects to move. What word do we associate with that work? Look at your definition that you wrote. Emily Mays? Force. Okay? And I want you to just add the word force in that definition for me. Okay? All right. Make sure that you've got that word force for the work. A force has to be exerted. Can you add the word exert? E-X-E-R-T. Exert. So let's talk about work. Anybody struggle with finding the unit of measure for work? Be honest.
I put force.
Okay, some of you made a guess. Okay, all right. So let's talk about that unit. What do you think the unit is? Or here, let's back up real quick. What do you know about energy? You need energy to be able to do work. In order to do work, you have to use. Okay, so are the two related?
Yes. They're like cousins.
Okay, the two, they're like cousins, Evan said. So if they're that related, what unit of measure do you think we use, Caleb? Joules. All right, so go ahead and write joules in there for me. All right, so as we're writing joules and adding joules in there, so fix it if you need to. I see a couple of you that need to fix it. All right, what can you tell me about power? Jesse already gave you a preview earlier. So what can you tell me about power, Hunter?
Rate at which work is done.
All right, it's the rate at which work is done. Okay, or energy is transferred. Who is that, Leslie? Good.
Oh.
Okay, it's the rate at which work is done or energy is transferred. And how do we measure it? Okay. Shylin, how do we measure it?
In watts.
In watts. What else did you see in there? Yes, watts.
Joules per second.
Joules per second. So if you can add both of those in there for me, Shylin. Okay. So do you have a chart filled in? Are all three related?
Yeah.
Okay. All three are related. We said that we needed energy to be able to do work. Okay. The more energy, the more power, the more work, you might need more energy. Okay, the more work there is, what do you think about power? All right, I tell Evan and I tell Virginia that they're going to push this table. Evan pushes it, and I give him the same amount of distance. Evan pushes it in 5 seconds. Okay, Virginia, it takes her 3 seconds. Who used more power? Who used more power? Virginia. Okay? All right. So we've got those three. So as we look forward and we look through our notes here, you've got your chart filled in. So let's move on to the next slide. Okay, let's think about page 281 in your workbook. Flip open to that homework section of your binder real quick. Periodically, we're going to check those workbook pages. Okay, your workbook pages. So as we think about this and we look at 281, I want to know what examples do we have of energy in this classroom? What were some that you came up with? And I'm just going to make a list and you can add to it. You can check yours, yes, but add to it. Don't limit yourself to 3. If you did not do the top of page 281, now's your chance to fill it in. So give me something, Jesse. The mood? How so?
Well, I probably shouldn't say mood, but it'd be like the amount of energy and work that they put into themselves.
Okay, so the more energy they have, maybe the more work they might put in.
Or maybe
Hopefully.
more enthusiastic.
Okay, let's think of concrete examples of energy. You're getting deep on me. Okay, and we'll come back to that mood. Okay, Stephanie, tell me.
Someone walking by.
All right, someone walking by, does that take energy?
Yeah.
Okay, whether it's teacher, student, walking by. I'm going to just jot these down. All right, what else? Trevor? All right, dropping something.
I got
All right, what do you got, Caleb?
I got what Miss Gillette told me. An electrical lamp lighting the room.
All right, so a lamp in the room. Do I have lamps in here? Okay, what else do I have? I got a couple. Savannah? All right, the air conditioning. What kind of energy is that?
That's heat.
Ooh, okay. All right, so let's talk about the air conditioner. How does the air conditioner start working, Trevor? Electrical. Okay. It will convert into some mechanical. Some systems run on chemical. So it just depends on the system. All right, somebody else give me another example. What's something else? Energy in this classroom. Hunter?
I think we already said it. I was saying I got it easy, like electrical, so the lights and.
All right, so the lights. What's something else that can fit in there? Sammy?
Pencils moving.
Pencils moving. Stylus moving. Carissa? The lights itself. We got electrical to light too, and so that's an energy transfer. Okay. Is the fish tank an example of energy? Yes. Okay, whether the turtles are in there moving or the actual filter itself, there's tons of energy in itself in there. Okay, so you should have a good list. Hopefully you added to your list so you had more than 3 things. All right, let's move forward. All right, so Mrs. Chen is going to be our friend, and as we look at our notes, Mrs. Chen is going to help us remember the main types of energy. So as you look at your notes, you've got the list, Mrs. Chen, in there. I see some of you attempted to fill it in. So let's double check your notes. And let's correct our notes in there. So Mrs. Chen, M stands for what class? Okay, mechanical. Notice kinetic and potential fall in that category. R stands for what class?
Radiant.
All right. S stands for?
Wait a second.
All right, keep up with Caleb here. Should we keep? What does C stand for? What does H stand for? Which is also known as thermal. What is E? Electrical. All right. And what is N? Nuclear. Okay. All right, so Mrs. Chen will help us to remember the main categories. Did we brainstorm more than this in the bell ringer?
Yes.
Yeah, and so some of those categories fall underneath. Like when you're talking about electromagnetic, where do you think that one might fall? Is magnets up there? Okay, probably electrical. Okay. All right. What we're going to do is I'm going to give you about 2 minutes as a table. You got a quick job, and you're going to work together as a table to make sure everybody is on the same page. What you are going to do is you're going to take 2 minutes. You're going to take the assigned. I'm going to assign you a type of energy. And your job with your table is you've got a chart. You are going to fill in the definition and an example for only that type. Okay, so table 7, I'm going to give you radiant energy. Table 8, I'm going to give you mechanical. Table 6, you've got sound. 5, you've got chemical. Heat is table 4. Electrical energy to table 3. And table 1 and 2, you both have nuclear energy. So I'm giving you 2 minutes. It's 2:05 right now. We'll come back in 2 minutes and share your results. Okay? All right, let's come back together. You were each responsible for one. Now, as we come back together, you're going to fill in the rest of the table. Okay? So let's start with table 8, mechanical energy.
Hello.
Okay? Which one of you would like to share the definition you came up with? Peyton, go for it.
moving objects, or adding potential and kinetic energy.
Okay. I would appreciate the rest of you be respectful. Okay. I heard moving objects.
And adding potential and kinetic energy.
Moving objects. I'm having difficulty here. There we go.
We don't have enough boxes.
Yeah, you do. You got 3 on the side and 4 at the bottom. So potential and kinetic energy. And I'll be right there, Caleb, to help you. All right, what's an example? What example did you come up with, Virginia? A soccer ball. What about the soccer ball?
When you kick it,
They're kicking a soccer ball. Let's add that. Find it.
Yeah.
Okay.
I'll just put these.
All right, yeah, that's fine. So, all right, so I've got mechanical up there. All right, table 7. Carissa, you got the definition for radiant or light energy?
Yeah.
What do you got?
Energy carried by light.
Energy carried by light. What's another word we maybe could use other than light?
Carried by sun rays.
Is it always sun rays?
No.
Not radiation. Close. Okay, think about, how does light travel? Not by, what did you say? Not rays.
There's space.
What makes the difference between red and orange and yellow? That's different colors, but what, Peyton?
Like, if you put different colors of glass, doesn't change colors? The light.
Okay, but what makes a color different, look different? Okay, something is communicating with my eye between the color of Savannah's shirt versus Michael's shirt. Okay, and it's traveling as what?
Energy. Thermal energy.
Shylin, was that you? Say it again. Waves. Okay, it's energy carried by waves. I just like to avoid using that word light because it's light energy, okay? So it's carried by waves. Now, not to be mistaken by ocean waves. All right, what was the example you guys came up with, Savannah? All right, so we're going to pick up where we left off yesterday. If you look up at the board, you've got your chart that we started with, and we were finishing up. I believe we kind of rushed through heat yesterday. So as we look at electrical, Lunar already told us in the bell ringer that electrical energy is very important to you. Okay, most of us probably wouldn't know what to do if we didn't have it at all. Okay, or we'd struggle. So what's the definition? Did you all have electrical? All right, so what's the definition for me?
Charged by particles. Movement of charged particles called electrons.
All right, so movement, and so we're going to write it in for those of you that don't have it. Excuse me. Movement of charged particles. What are those charged particles called? Electrons. All right, and what was the example table 3 came up with?
Outlet.
An electric outlet. All right. Now I had 2 tables in charge of nuclear energy, so we're going to let one table define it and the other table add to it or compare. So Leslie's got her hand up. So Leslie, why don't you start for us?
Nuclear energy is energy. I can't read my own handwriting.
All right, so work
Energy
together.
Released when combining fusion or breaking fission atomic nuclei.
All right. So it's energy released. In table 2, we're going to come over to you to see if you have anything to add. So energy released. I'm pulling out what I heard Leslie say. When atoms undergo fusion or fission. Table 2, do you have anything that you would add to it? Or anything else that you found? Does that match up for you? Does that match up, Haley? What you got? Yeah. All right, table 2, what example did you come up with?
Found in the sun's core.
All right, so we've got sun's core. Leslie, did you all come up with anything different? A nuclear power plant, good. So we got 2 good examples up there. All right. So do you have your chart filled in? You got some good examples. You got some good definitions. And as we move forward, what we're going to do, and if you're needing this chart, I'll pull it back up in a minute. Okay, but as we look at that learning target, bless you, I can identify different types of energy. I'm a firm believer that you got to hear it different ways. So you guys know Tim and Moby? Yeah? Can I get a yes? Okay. All right, so we're going to take a minute and we're going to watch Tim and Moby here. Okay? It's about 2 minutes, so give Tim and Moby your attention.
Okay, just relax and keep your eye on the target. Well, that was closer than last time. Dear Tim and Moby, what is energy? From Lily. Energy is what makes matter move or change. It's the ability to do work. When the bow is stretched like that, it has potential or stored energy. We know that as soon as Moby releases the bow, that stored energy will be released as motion. The potential energy will transfer to the arrow. The arrow moving through the air has kinetic energy. That's the energy of motion. Not bad, you hit the target this time. Well, the bow does work on the arrow when you release it, and the arrow does work on the target when it hits. Energy comes in a bunch of different forms. There's chemical energy stored in food that your body uses to walk, run, and lift things. Power plants and batteries provide us with electrical energy. The sun is our major source of light energy. Wind, moving water, airplanes, and sound waves all have mechanical energy. Vibrating atoms cause heat, and that makes thermal energy. Nuclear energy is released from inside atoms when they are broken apart or fused together. Nice shot. Hey, you're becoming a pro at this. No way. There's no way I'm letting you shoot this apple off my head. Forget it.
How many of you would let him shoot an apple off of your head? All right, I got a couple hands there. All right, so as we move forward, I can identify the different types of energy. How do we remember that? What's the saying? Who do we think of? Mrs. Chen. And so that's what we're going to work towards today as we work in class and on our activities. So keep your notes handy.